Hi, this is Steve Walton from Tropic Heating and PatioHeat.com. Today I'm going to take a look at this beach house here. So we have a couple of areas that we want to address. First, there's this very narrow balcony that the customer would like to see if we could heat up. And then there'll be an additional balcony built in the back. And that's a second area that they're looking for. I want to go ahead and just put the dimensions on here. So our ceiling of the lattice up here is 8 feet 8 inches roughly. There's a section here that's 12 feet or 11 feet rather. And then we have another section here 8 feet and another section that's 12 feet that goes out to this railing. In the front we have, it's a very narrow, roughly 3 feet wide. So I have it at 210, so this is 2 more inches, so that'll be 3 feet wide. And then of course the height I think is it's roughly 8 feet I think up to here. Let me just put that on here real quick. So I'm going to use this beam right there, and here we have 7 feet 8 inches. So that's our total height. The length, I'm not going to go through the length right here because it's not that imperative, and I'll show you why here. So the only possibilities that we can really do here would be some sort of electrical heater. These are C4024s, 4,000 watt 240 volt. And as you notice here, I have some limitations. There's a glass window here, and there's actually a glass sliding doorway here. And where I would have liked to have put them up on this beam here and maybe a little bit higher up here, I have an issue with that because I need to keep a clearance of 6 inches from this edge to, oops, let me get here, to this edge here if I was to place them up there. But the issue is, and I'm going to do something new that I haven't done before, and that is to show you the clearance required for this heater. It's depicted in this reddish tone here, and you can see that I would not be meeting the clearances if I brought this heater up higher. And we got this 18-inch clearance below, and we would be, oops, see, we're even touching the way it is right now, so I technically need to move it over slightly a bit more. Let me just go ahead and do that 1 second here. And let's just move this. There we go. So you can see how my measurements even are closer, but yeah, I'm still meeting the 6 inches required up here by lowering the heater and making a bracket to have it fit on. But it's not a very good application. So the other thing that again I wanted to worry about, and I'm going to put the ray on now. This will be the infrared ray, the output of the heater. You can see that placing the heater, even with the clearances, that I'm starting to penetrate this glass awfully close, and on a cold day this upper section of the glass is going to be the same as the ambient temperature, where the heat penetration will be a direct penetration of line that goes across this glass, and this glass is going to be unevenly heated and could potentially fracture. So that's an issue. I don't like this application at all. I don't know what else to do here. I mean, you could put the heater underneath here, but that would be a really big obstruction. It's already an obstruction the way it sits. And you can see here that the height being 6 feet 11 inches off the ground, which is okay. I'm a 6'3" guy. And if you're reclining here, that would be okay. But again, I don't like the idea of blocking a window, but that's the only way we can physically do this application up here. So let's turn that off. So I don't really have a good solution for this section of patio because of its depth here. So let's go back over here. There's two different options that we can use here. That option would be a gas heater, and as you can see that the gas heater, its elevation would end up being the 6 foot 10 inches off the ground, which is rather low for this model. Also, I did state that this is a beach application and you have a predominant wind coming through this direction. Gas heaters don't work as well when it's windy, so that's something to be concerned about. Also, I have this heater centered in the patio and 9 foot centered throughout the span. You can move them left to right or closer to the house or further away depending on how you would like that. But again, I'm still not happy with this. You can see the heat footprint really needs or requires the heater to be higher up off the ground to really produce a good footprint of heat. So let's turn that off and we'll look at the electric options. So these are the same models that I showed in the front, which is a C4024, 4000 watt 240 volt. Again, they're centered, 5'6" from the outside edge to the center of the patio, and then 9 feet off of each other. Now this heater here is going to be more suitable for this type of application because it's going to be rather higher off the ground, so almost 8 feet off the ground. And let's look at the footprint of heat. You can see the spread is a lot nicer. You got some overlapping here in the middle, which is perfect. And again, 9 foot center off of each other. Another thing that I mentioned before is the fact that these are electric heaters. So with the electric heaters, the wind does not affect the output of the heater. There's no moving gases. And so the efficiency of the electric heater is always 100% in windy conditions. So this would be the ideal application for this this patio deck here. So there you go. If you have any questions or if you're looking for some assistance with your outdoor heating needs, we're here to help. My name is Steve Walton from Tropic Heating and PatioHeat.com. Thank you and have a great day.